Greetings, this is Berry-Fletcher, and this is my another attempt at a presentation on Jean Piaget. Jean Piaget was born and raised in Neuchâtel, Switzerland. His father was a professor of medieval literature. He is best known for his theory of cognitive development that largely addresses early childhood and adolescent development, which begs the question about how this applies to higher education. Well, it applies to higher education because the theory known as constructivism is widely attributed to Piaget in terms of individual constructivism. Simultaneously, Vygotsky and Dewey were credited with developing the theory of social constructivism, which is essentially the same concept except with a very significant twist, which is around our social connections and our relationships with others as influential in our construction of knowledge. But let's go into constructivism a little bit more deeply. To do so, we need to remember that Piaget had a theory of childhood and adolescent cognitive development that had 4 stages, still does have 4 stages, and the last 2 stages, concrete and formal operations, are the stages that we are most concerned with in higher education because they are the stages we are often trying to nudge students from the concrete to the formal. Why is this? Because in concrete operations, students have a very basic rote level capacities to classify information, to understand how to conserve, which is to understand that when liquid is moved from one vessel to another, the amount of the liquid is the same regardless of the shape of the vessel. Hanging on to that information makes it possible to hypothesize or to make inferences or generalizations about information. I'm going to get into this a little bit more because this is kind of important to higher education and a lot of the learning outcomes that we talk about. It's not entirely clear sometimes how folks would arrive at these higher order learning outcomes. So in order to understand Piaget and his learning outcomes, it's interesting to know that he was educated in his earlier years, high school and college, in the areas of biology. So he was very interested in mollusks, for example, and also in birds. And even in this picture, the idea of mollusk, the idea of shellfish, as a common element among these objects is a point that he would make, which is that the student would go from the concrete, that's a clam, that's a squid, to the more general schema of shellfish. And the connections between the clam and the squid, for example, of course the squid isn't a shellfish, but whatever, the connections that the student makes between those are associations, and it creates a schema. So this is a schema known as mollusk. So that information, being an empiricist who studied animals adjusting or adapting to their environment, was complemented by his training in psychoanalysis, where he learned about associations. So what we have here is empiricism. The animal has the inputs and tries to make sense of and adapt to the inputs from all the senses. And then we have associationism, which is a higher order thinking, where we connect one idea with another idea. For example, a person who has a trouble at work delegating work, one asks the person, well, what do you associate with delegating work? What are the ideas or thoughts or images that come to your mind? And the person says, if I delegate work, I will lose control. Well, that's an individual schemata. That person has constructed their knowledge of or their thinking about delegating work to conclude that if they do so, they'll lose control. Whereas another person with that same set of variables, that same idea, you should delegate, will conclude, oh, gee, I'm going to be able to have a lighter workload, or I'll feel freer. So each person's idea of the word delegate, for example, is very different and idiosyncratically constructed through their experiences. So he proposed, beyond his theory of development, he proposed types of knowledge. Physical knowledge, where we code issues such as shape, in this case sphere, and color. We construct social knowledge, which is the understanding of the symbols and what they connote for the culture. So the green clover obviously means St. Patrick's Day, and the heart is Valentine's Day, etc. And so we understand how to connect these images and symbols with a whole series of social phenomena. And then last but not least is the logical mathematical knowledge. And this is really most germane to the development of schemas and the topic of assimilation and accommodation that then relate to learning outcomes, higher order learning outcomes. So schemas are, you take these individual items, they are all balls used for playing sports, but we put them together and we come up with sports. And so each person who is exposed to the culture will come up with some kind of schema. What's kind of interesting is that not everyone who's exposed to all of these sports equipment is going to come up with the same term. And that's what constructionism is about, is that we're not all a monolithic whole who interpret the same images and ideas and concepts to have the exact same conclusion. But there are some general shared sets of knowledge. And how do we get to these? Well, we do them through two different processes. The most basic one is what we do when we take new information, we add it to existing categories. So here we have a child who's in school and her teacher saying, a zebra is a beautiful animal that lives in the plains of Africa. And then when she comes home and she represents this to her mom, she says, we learned about striped horses that live in tall grasses. So she has assimilated the zebra into her existing framework of horse. If she were to accommodate, that would mean taking the two categories, the dog. So you think about dogs. Dogs have four legs, they have ears, they have tail, they bark, they're furry, and they lick. Then you have a cat, four legs, ears, tail, but meows and climbs. And so meowing and climbing don't fit with the schema of dog. So to accommodate this new information and to rectify the disequilibrium that this new information that doesn't fit with existing category, dog, creates, the equilibrium is restored by the creation of a new category called cat. And that's accommodation. So when stuff doesn't fit into the existing categories, we create a new one in order to settle ourselves down and to make sense of new information. Constructivism is all about that we each do that in different ways. And some of the stepping stones to doing so are conservation, where we hold on to the idea of a horse or the idea of a dog or the idea of a cat, but we broaden the number of categories and the number of categories into which those different phenomena can fit. So what are the implications of all this for higher education? Well, a couple. First is that in Piaget's thinking, the process of thinking matters through rather than the right answer is to be the focus of education. In other words, it's the means to the end versus the end, or the process, not the product, that we are aiming for. We are hoping to teach people to think, not what the conclusion of the thought is. So that logically leads to instructors should avoid giving the punchline, avoid saying, okay, all of these are mollusks. Rather, one would ask, what do these organisms hold in common? And that we should recognize that development is recursive. In other words, we pick something up, we go back, we revisit it, and we expand upon it. So given that that's how people learn, we as instructors would want to provide opportunities to cultivate or to nudge students toward the next level. So going from formal to abstract reasoning, for example. And we want to present information from the basic operational to the abstract in that order. So I'm going to give an example. In terms of higher order thinking, Hewitt and Hummel reported that about 35% of all adolescents are capable of abstract thinking. That's pretty interesting, and I've read other studies that have shown that about 50% of all adults at any given moment are thinking concretely. They are not thinking in the abstract. So what does this mean for us in terms of instruction and pedagogy? Well, it means that we need to be aware that students need more opportunities to exercise their abstract reasoning muscle, their higher order thinking muscle. So, for example, this set of images is a logic puzzle. We've got a yellow block on a horizontal, and then on a diagonal, and then on a horizontal. And then logically speaking, we know that the next is probably going to be a blue on a diagonal. And the idea is that we don't explain that we ask students to think and to infer what is happening next. And to infer requires a degree of conservation of this set of images, and then thinking what does this predict going forward. What the critique of education that emerges from this is that we provide too much of the, and so the next block is going to be blue and it's going to be on a diagonal. The idea is to encourage students to not only figure that out, but also to add to the puzzle by saying, well, what do you think would make this puzzle more interesting? And perhaps the answer would be a circle, and then the puzzle would become more complex, but it would be the student's construction and us guiding that construction versus providing it. Higher order thinking can be taught, and I'm just going to go here from the pre-operational to the formal operations because it's kind of interesting to do. So you've got these little cubes, 4 and then 5 cubes, then are placed on the bottom left in a cluster of 9 cubes. So we have a literal depiction of these cubes. Then they are represented in a drawing, almost exactly as they are presented, but now this is representational, which is we've gone from the most basic to the mid-range of operational thinking, so that you can understand that the cubes represent, the drawing of the cubes represent the actual cubes. And then the digits represent the cubes, and that's at formal operation. So now we are able to recognize that a digit represents something else. We don't have to literally see the cubes in order to recognize that these digits represent it, and that this is how addition and then multiplication and fractions and division and so forth are learned. So what are the conclusions? The conclusions are that through the process of experiencing the world, experiencing lectures and readings, and actually going out and applying that knowledge, interviewing someone to ask them, doing the experiment on the conservation of fluids, for example, that students construct schemas. And schemas are linked by associations. And these schemas are created by assimilating, which is adding to existing categories and adding to existing schemas. And they're also challenged when experiences don't fit existing schemas. And so in that case, we will accommodate by creating a new schema. And the goal of higher education is to help to create increasingly complex and increasingly varied schemas in order to construct processes, cognitive processes of abstract reasoning and higher order thinking, because that is what we are aiming to do in higher ed. Thank you so much for listening.